Hello, let's go ahead and work on a lecture here on representing data. So this will be in some ways similar to the last lecture where we talked about organizing data and gathering data, but here we're going to actually talk about how to actually represent our data in a way, how to format our data in a way that the results of that data can be interpreted very easily. So really everything I just said right there in that sentence is just a fancy way of saying, let's make a pie chart, let's make a bar graph, let's make some sort of graph, let's make some sort of figure that lets us draw conclusions about the data that we have. Just listing the data while it's helpful for you, the person actually taking the data, doesn't necessarily help someone else understand that data. So as we've seen before, there's a lot of ways that you could represent data, but we're just going to focus in on two. We're going to look at pie charts and bar graphs. So let's go ahead and start off with a pie chart example. So we're gonna say that we went out and we did a survey where we looked at grocery shoppers and whether or not they use their own reusable bags. So maybe you stood outside of a grocery store and you asked people. You said, all right, how often do you use reusable bags? Do you use them always? Do you use them never? Do you use them frequently, or do you use them occasionally? And so with that, we've got these responses. So these would be the responses of our survey. And we want to make a pie chart to represent this data. And so what we could do is we could first start off, we could say, all right, we have the number of people that tell us or that told us these answers, but it would be helpful if we're doing a pie chart to have percentages, right? So we want to actually figure out the percentages of people that said always or said never, or one of these answers. So first things first, we should figure out how many people were actually surveyed. So what you'll notice here is that if we take the 10 people plus that said always, plus there was 39 that said never, there was 19 that said frequently, and there was 32 that said occasionally. If we add all these up, we actually get a nice even 100 people. And I've done that just to make the numbers easy here. It's not always necessarily going to be that simple. So in this case here, well, in all cases, but in this case here, our percentages will be simple. In the general case, we'll have to actually divide them out. Here we could say, all right, for the people that said always, there are 10 out of the 100 people. So that's going to be 0.1. You could alternatively just say 10%. And then we could go down the line. We could say, all right, never was 39 out of 100 is 0.39, which is 39%. And then we have frequently, that response. There were 19 people, so 19 out of 100. And you're kind of seeing a pattern here. This is going to be 19%. These percentages work out nicely just because it's being divided by 100 people. Obviously, it's not always 100 people. And so our percentages might be different. Let's go ahead. Occasionally, finishing this up, 32 out of 100, 0.32. 32%. So we've got these percentages of people that responded accordingly. And with these percentages, we've just calculated them by taking the number of people that said the given response divided by the total number of people surveyed. And so making a pie chart here should be fairly simple. We might be able to just look at this and say, all right, cool, let's make a pie chart. And if we take this, we'll have, that's not what we wanted. If we take this, we'll have 10%. And I don't know, that looks about like that. 39%, how much does that look like? Like that much. And then 19 and 32, I don't know, maybe that much. And here's the thing is that this can be kind of difficult to make a pie chart just by guessing at what these percentages look like. If you don't get it quite right, your percentages might look disproportional. And this is a perfect example of me trying to do that. Just doing a very quick example of that. This almost looks like 50%. And I kind of messed that up a little bit. So that's actually just sort of a this is a perfect example here of why we don't like to just sort of freehand this, why we actually want to come up with a way to do this more carefully. And so what we can do is we can actually note that a circle has 360 degrees that goes all the way around. So you can hearken that to, saying maybe, someone did a 360 or they did a 180. If someone does a 360, they spin around in a complete circle. So the circle has 360 degrees all the way around it. And we know that, for example, the people that responded always comprise 10% of that. So if we actually went through and we said, all right, 10% of that 360 degrees is going to be 36 degrees. Now we know we could pull out something like a protractor and we could actually measure 36 degrees out. We could get an exact portion of this pie chart that represents the always category. And then with never, frequently, and occasionally, the same thing. We would take these percentages and figure out how much of that 360 we want to encompass. You'll notice that if you add all of these up, you get exactly 360 degrees, and that's expected. We should get the entire pie chart. So we'll take these degrees, and if you had a protractor, you could measure out these degrees, and you could mark your points here, and this is exactly what you'd get. So what you'll notice here is that this right here is exactly 36 degrees. That corresponds to that 10%. And then likewise, the never angle right here, that's 39%. Remember, that corresponds to 140.4. So this is going to be 140.4 degrees exactly, and then so on and so forth with the occasionally and frequently. But here we've actually done a great job of taking these percentages and basically converting them to degrees, and then that gives us a nice simple pie chart that we can make. And the reason we want to do this, as we've stated, is so that someone can just look at this pie chart and they can just very simply interpret what's going on here. And so just to here, let's copy this page over. So we'll do the same thing. We don't have those markings on there. So looking at this, someone could take this pie chart. It's very clearly labeled where it's where each of the responses, what each of the responses were, as well as the percentages. Sometimes you'll see the percentages written inside the pie chart. I personally like to write them outside. I think it's a little bit cleaner. But we've got very nice labels here. We've got a pie chart that shows us the portions of people that responded which, and someone who's looking at this can very clearly see that most people say never or they say occasionally, and then there's fewer people that say always and frequently. And it's just very easy for someone to look at this and actually figure this out, as opposed to having to just look at your data as it was stated in just sort of a sentence format. Obviously here, as I've said a couple times, the percentages turned out to be just these exact numbers, but they're not always so nice and pretty. And so looking at this just in a sentence format, that's not really that helpful. This is listing our data and sort of the frequencies of who said what, but it doesn't nearly get the point across as well as this pie chart would. So we've got that pie chart there. You do want to be careful about drawing these pie charts accurately. If you draw a pie chart in your always region, which was 10%, looks like this, that's not going to be good. That's not going to be viable, because this looks like 25% to me. So you want to make sure that your regions are accurate. A protractor is great for that, and doing this sort of degree method that we did. So there we go. We got pie charts. So now let's move on to another example. We're going to do the same exact example, but we're going to show a different way of actually representing this data. And we're going to look at a bar graph. And so this will actually, this is fairly straightforward how we make this. So we've got the same exact example. We've seen these numbers. We've been dealing with them. Basically, our bar graph just says, all right, let's just have an X and a Y, and we're going to label them. So we're going to say, hey, the number of people that responded always, never, frequently, and occasionally. And then we just make bars that correspond to the numbers of people that said each of these things. And so you'll notice right here that the number of people that said always just perfectly matches up with 10. And then the number of people that said never perfectly matches up with 39. Frequently was 19, and then occasionally was 32. And this is actually something that I like to do a lot. I really like to write these numbers right across the top. That way it's very clear what those numbers are. It might be tough for someone to think, hey, is this 39 or is it 40 or is it 38? Maybe they don't draw a perfectly straight line across, or they just kind of read it incorrectly and think that it's 40. So I like to write these numbers at the top. And in that line of thinking, labeling is key here. You have to label your axes. Here on the y-axis, I've labeled number of people. Here I've labeled each of the response types. Maybe if I wanted to, I could actually have another label that said response, just response, right? These are the responses that people said. In a case like this, it's pretty clear that these are responses. And then actually what I probably should have here is I probably should have a title as well. Always have a title of a graph. That would be good. So we could say reusable bags. And we could maybe come up with a better title than that, because this doesn't even tell us anything. Reusable bags, well, what about them? So a detailed title is good. Make sure the big things are labeling your axes. You'll notice I also have my tick marks here and my labels there. So make sure that you've got all that on a bar graph. And it's really just a different way of explaining, hey, here's the responses. It's just a little bit different of looking at a pie chart. Maybe it's a lot easier, or let me back up. So let me say this differently. When I look at this, maybe I forget to label these percentages and I just have a pie chart. Well, this region here and this region here, they kind of look similar, and it would be hard for me if I didn't label these percentages. It would be hard for me to figure out which one of these regions is larger. And that's where the bar graph is super helpful, because it's very easy. It's very clear to see that this is in fact larger. And so a bar graph has its own uses. You'll notice here that I wrote number of people, and so these are all my numbers. If I had written percentage of people, that might possibly change the heights of your bar graphs, of your bars. So there's bar graphs and pie charts there. One last thing I want to mention with them is that in certain cases, one of these or the other does a good job of representing your data and one doesn't. A very simple example of that is a pie chart does a very poor job of representing data where someone can respond with multiple answers. So maybe you're saying, you're asking someone, what's your favorite food, or maybe not that, because that's an exact, favorite food would be exact. Maybe someone says, which of these foods that I'm about to list do you eat frequently? And maybe I list apples, bananas, and oranges. And maybe you eat apples and bananas very frequently. You eat them quite often. And so you would say, hey, I eat both of those frequently. Well, a pie chart is not going to do a good job of representing the number of people that stated apples, that stated bananas, and that stated oranges, because there are some people that answered for both. And so actually the total number of people surveyed is going to be less than the number of answers that you got, the number of responses. And a pie chart doesn't do well for that, because for a pie chart, you have to have exactly 100% of your data represented here. And so if you had more responses than number of people that you surveyed, a pie chart isn't going to work. And we'll see some examples of that as well. So let's move on. We've seen bar graph, and we're going to do a very slight difference, very slight variation on a bar graph. We're going to talk about a histogram. And recall when we talked about frequency distributions in the last lecture, we said, all right, there's two ways we could do this. We could just list we could list each thing and list how often it pops up. But in certain cases, for example, with these highest recorded temperatures in the states, it made more sense to make intervals. So we made intervals. Hey, let's count the number of states between 100 and 104 degrees, between 105 and 109 degrees, and so on and so forth. And those intervals were helpful because it sort of broke down our data into a much easier way to list. And this is the same thing with a histogram versus a bar graph. A bar graph is great in certain cases, but also a histogram works better than a bar graph in others. They look very similarly, but a histogram is going to be a bar graph where we're looking at the frequency of data in intervals. So let's go back and let's look at this example. So we've got these highest recorded temperatures in each state. And so if we make our frequency distribution with our intervals, we say, hey, here's my intervals, 104, 100 to 104, 105 to 109, and so on and so forth. We've got all these intervals. And we've got our frequencies for each of these intervals. And then what we can do is we can make a bar graph where basically we just write down, hey, here's my interval, and then give it a bar of height 3. Hey, here's my second interval, give it a bar of height 8, and so on. And when we do this, you'll notice that my 100 to 104 is right here at 3. And then we'll have our 105 to 109, and then so on and so forth. And that had a height of 8. And so we've got that all nice and listed here. And this is a histogram. Now, obviously, it looks like a bar graph, but there are a couple little differences. What you'll notice here is that we tend to actually connect these. So back on that last bar graph, we had spaces in between each bar. On a histogram, we tend not to do that because when we're grouping our data, it tends to just flow naturally from one to the next. And so we don't really want to bother with separating our bar graphs. Our bars, we don't want to separate. And so that's one big difference here. Another difference is that I don't actually explicitly list the intervals. You'll notice I just write 100 and then 105. And so that's actually assumed that it's 100 to 104, just kind of right up to that edge. And then this bar represents 100 to 104. This bar represents 105 up to 109. Some people will actually explicitly write out like a 104 and a 105, maybe with a dash there or something. That's not as common. It's more implied that the number here is the start of each interval that we have, and the final number is one more than that interval. So 100 to 104, 105 to 109, 110 to 114, and so on. And so we've got our histogram here. Again, we have labels, we have temperature, we have number of states. Maybe a title would be good to include here. And we've got our histogram here. And so a couple of things that I notice this shape. I'm not going to talk about that yet. We'll talk about that in future lectures, but I just want to point that out. This is a very common shape that you see where everything is kind of bunched up in the middle right here. And then the other thing I want to mention is, who says that we have to do these intervals? Why can't we change our intervals to be something different? You'll notice each of these intervals has a width of 4. And who says that I can't have different widths? Well, you're totally allowed to. And so what we want to actually see here is it depends on the data, right? And so when we look at our data here, you might want to take a look at all of this very carefully. Maybe make a stem and leaf plot of all of this data. Maybe just list the data from smallest to largest. Maybe that'll help you organize it a little bit better. And when you have all that, that's nice, because what that does is it allows you to make a smart decision on the number of intervals that are required. Something that wouldn't be smart, recall that we saw 100 and 134 were the smallest and the largest. It wouldn't be smart to make 34 intervals here, because that just means that every interval would be 100 to 101, and then 102 to 103, and then 104 to 105. And if every interval just has a length of 1 or 2, that just doesn't really capture the information here. And then likewise, we don't want to have intervals that have a width of 17 per se. That would mean that one interval would be 100 to 117. And then the next interval would be 118 up to 134. And that's not good because that just splits our data in two. It just doesn't really help us actually break apart the data enough. And so a balance is needed in order to find the appropriate number of intervals. And it really just depends on the data that you're given in the situation at hand. A good rule of thumb is to do 7. Again, that's just it's a basic rule of thumb. That's not a guarantee. That doesn't always work. It's not always helpful to do 7. But in a case like this, I've done 7 here, and it works out fairly nicely. In a lot of cases, 7 will work. In some cases, it won't. In some cases, it makes more sense to do 3 or 4 intervals. So continuing on with this talk about intervals, we've said here, I have 7 intervals. Well, how did I actually figure out that I wanted a width of 4? So in order to get my 7 intervals, how do I know that a width of 4 will do it? Well, one way is just to guess and check. You could just say, hey, I want 7 intervals. I recognize my high and my low, or excuse me, my low and my high. So I recognize, hey, there's 34 right there. So there's a difference of 34 between the lowest and the highest data point. And so I could just start guessing and checking. I could just say, you know what, let's try making an interval of 3. Let's try making an interval range of 4. Let's try making an interval range of 5. And when you do 4 and you work it out, you'll notice that you have 100 to 104. All right, the next number is 105, add 4 to get to 109. Next number is 110, add 4 to get to 114. And you do this, and all of a sudden you get right up to that highest data point, and you have exactly 7 intervals, and you're encompassing all of your data between 100 and 134. And so that right there, that range of 4 was a good choice. And we just kind of got that by guessing and checking. Another thing that you could do is you could actually take the range of your data, and without really mathematically defining that, we'll just say, hey, this is the largest minus the smallest, and this is 34. You could take that number here, and you could divide that by the number of intervals that you want. In this case, 7. And you'll notice here that 35 divided by 7 would be 5 exactly. So 34 divided by 7 is going to be just a little bit smaller. It's actually going to be 4 and I'll do a mixed number here just to represent it. It's going to be 4 6/7. And so what I would do here is then I would take this number and I would round it down to 4. And that's a good indicator of what my range should be in order to get me to encompass all of that data. And so there's a handful of ways that you can figure out, hey, if I want this number of intervals, in this case 7, what should I make my interval range, in this case 4? You can guess and check. You can actually do this sort of method here, if you will, where you just find the range of your data and then you divide it and round down to the nearest number. And that's that way will work. Guessing and checking is a great option as well. But once you have your 7 or however many intervals, and once you have your appropriate interval widths of 4 or whatever you decide to do, you'll make your histogram here, and then you're all good to go. The last thing I'll mention here is that you could actually do different interval ranges and still end up with 7 intervals. What we'll notice here, I'm not 100% sure if this will work, but we'll try it. 100 to 105. Let's do a range of 5 here. And I'm just going to keep counting up. You'll notice that I'm adding 5 for the interval width, and then I'm going 1 more just to get to that next number. We'll keep on going. We've got 5 so far. 130 to 135, and then 136 to 141. You'll notice here that these are my 7 intervals. But the problem with doing this actually is that there's nothing in this interval. There were no states that had a high temperature between 136 and 141. So it's really, there's just no point in even putting it there. We might as well just get rid of it because there's just nothing in it. So here, actually, if we did a range of 5, you would have 6 intervals. If you do a range of 4, you'll have 7 intervals. In some cases, that doesn't always happen. In some cases, you could have different interval widths still give you the same number of intervals. It's really just a matter of just trying them out and figuring out what's the best. It really just depends on your data. And obviously, different interval widths and different number of intervals will change the numbers that go in in this frequency column. Because if your intervals are different widths, then you're going to be encapsulating different data, and so your frequencies will change. So there's that on histograms. We'll get some practice with that. Take note of the labeling and also the slight differences where we connect all of our bars right here, and the sort of weird thing where we say, hey, this bar right here corresponds to this number up to 1 less than the second number. There we go. So that's histograms and pie charts. We'll go ahead and call that for the lecture.